Hi, welcome to lesson 4 of arcs, sectors and angles and circles. Today we're going to look at some problem solving examples involving arcs and sectors. You should be getting used to the routine by now, so remember, just like before, where you see the notepad and pencil icon, copy the notes and examples into your notes jotter or complete the exercise at the end of the slides into your class jotter, please. Remember to use the pi button on your calculator for accuracy, but if you don't have a pi button, then 3.14 is absolutely fine. Okay, same as before then, we're going to have a quick pause of the video so that you can have a go at the lesson starter. So here we have a circle with a radius of 10 metres and a minor angle of 80 degrees. And you're asked to calculate the length of the minor arc, PQ, and calculate the area of the major sector, POQ. So have a go at that just now, please. Okay, so let's have a look at the answers to the starter. So, question A, we have to calculate the length of the minor arc, PQ. So, if the radius is 10 centimetres, then the diameter is 20 centimetres. Remember, your formula for the minor arc is the fraction times the circumference, so it's 80 degrees divided by 360 degrees times pi times 20. And we get an overall answer of 13.96 centimetres. So the length of the arc PQ is 13.96 centimetres. If we look at B, the radius is 10 centimetres and we are being asked to find the major sector POQ. So therefore we need to find the major angle. So we need to do 360 degrees, take away 80 degrees, which gives us a major angle of 280 degrees. It's the major sector that we're trying to find. So remember, your sector is a fraction times the area of the circle. So that will be 280 divided by 360 times pi times 10 squared. And that will give us an area of 244.35 square centimetres. So let's look at today's lesson. So today we're going to be looking at problem solving using arcs and sectors. By the end of the lesson, we should be able to recognise common types of arcs and sectors questions. We want to be able to break the questions down into steps and complete the questions using appropriate working and units. So let's look at a first example. Remember to pause the video and copy this into your notes jotter as you go. Here we have part of a circle with centre O and radius 36 centimetres as shown in the diagram. The angle at the centre, AOB, is 140 degrees. We've been asked to calculate the length of the arc, AB. So, first of all, the radius is 36 centimetres, so the diameter is double that, so it's 72 centimetres. Remember your formula for arc length. The arc is a fraction of the circumference. So, arc AB is 140 divided by 360 multiplied by pi times 72. Remember, circumference is pi times diameter. And that will give us an overall arc length of 87.96 centimetres. Here's example number 2. So it's getting a little bit more complicated here. A fan has 4 identical plastic blades. Each blade is a sector of a circle with radius 5 centimetres. The angle at the centre of each blade is 64 degrees. We have to calculate the total area of plastic needed to make the blades. So we need to think about this a little bit more carefully. So our strategy needs to be find the area of one blade, so that's the area of one sector, and then multiply this by 4. So if we want to find the area of one sector, we need to know that the radius is 5 centimetres. And remember that our sector is equal to a fraction times the area of the circle. So one sector, or one blade, is equal to 64 divided by 360 times pi times 5 squared, because area is pi r squared. And if we put this into the calculator, we will get 13.96 square centimetres. So the area of one blade is 13.96 square centimetres. But remember, there are 4 blades. So we need to get our total area is 13.96 times 4. So a total of 55.84 square centimetres of plastic is needed. Our last example, example 3, we have been asked to calculate the perimeter of the green shaded section. So remember, perimeter is the total distance around the outside of a shape, so we want to get the total length around the outside of this green section. So our strategy here would be, we're going to label the green shape ABCD at its vertices. We're going to find the length of the outside arc AB. We're going to find the length of the inside arc DC. We're going to find the length of the edges AD and BC, and then we're going to add them all up to find the perimeter. So firstly, arc AB. So from the diagram we can see that the radius is 8.1 centimetres, so the diameter is double, which is 16.2 centimetres. Our arc AB is a fraction, so 120 divided by 360 times the circumference, so pi times the diameter of 16.2. And if we work this out, we get a total arc length of 16.96 centimetres. For arc DC, the radius this time is 3.7, so the diameter is double this, which is 7.4 centimetres. Arc DC will be the same fraction, 120 divided by 360, multiplied by the circumference, which in this case is pi times the diameter of 7.4, and that will give us an overall arc length of 7.75 centimetres. For the edges AD and BC, what we need to realise here is that the point of the sector is the centre of the circle. So OC is equal to OD because they are both radii. OA is also equal to OB because they are the longer radii of the outside. So therefore we can say that the distance AD, or the distance BC, is 8.1, take away 3.7, so the distance AD or BC is equal to 4.4 centimetres. Now we can calculate our total perimeter. So 16.96 plus 7.75 plus 4.4 plus another 4.4. So we have a total perimeter of 33.24 centimetres. Okay, now it's your turn again. So just as before, you'll complete the questions into your class jotter. Remember your formulae, your sums and your answers with units. And then once you're finished, you can check and correct your work at the end. So pause each slide for as long as you need to complete the question. So here goes.